What is quantum computing?
There's no bits that are 0 or 1. Quantum computers use qubits, which can exist in multiple states at once, creating unique opportunities for solving certain types of problems.
Myth: quantum computers replace all classical computers.
A common myth is that quantum computers will soon make regular computers obsolete. In reality, quantum computers excel at specific tasks like factoring large numbers or simulating molecules, but are not suited for everyday tasks such as word processing or browsing the internet. Classical computers will remain essential for most applications.
Myth: quantum computers can solve any problem instantly.
Contrary to popular belief, quantum computers are not magical problem solvers. They offer speed-ups only for certain algorithms and problems. Complex issues like traveling salesmen or general artificial intelligence still remain challenging, even with quantum hardware. Quantum speed-up depends heavily on the nature of the problem.
Myth: quantum computers are already unlimitedly powerful.
Current quantum computers are still very limited. Today's machines have only dozens to hundreds of qubits, most of which are prone to errors and require extremely cold environments. Large-scale error-corrected quantum computers, capable of revolutionizing industries, are still years or decades away.
Fact: quantum computers are a complement, not a replacement.
Quantum and classical computers will work together. Quantum devices can tackle certain calculations more efficiently, while classical systems handle general tasks. The future likely involves hybrid solutions, using each type of computer for what it does best, helping researchers, businesses, and society as a whole.